last period. There we go. So if we're factoring by grouping, we're going to start it out the same way. We always got to check for a GCF first. I don't see one here because we have a 3, a 4, and a 1 as our coefficient. So we really do not have a GCF. But then I'm going to use my same tools. I'm going to take that X frame like we used yesterday where we have our A times C at the top. My A is 3. My C is -4. So we have -12 at the top. And our B goes at the bottom. It's at -1. We need a pair of numbers that multiplies to make -12 and adds to make -1. 3 and -4. So -4 and +3. Those will multiply together to make a -12. They add together to make -1. Again, that tells us how these two, how this x was before we combined our like terms. So this is 100% the same thing as if I wrote 3x squared minus 4x plus 3x minus 4. It still means the same thing. I didn't change my equation or my expression. I just changed how it looked. If I combine those terms back together, I would 100% have what we had at the top. When we're factoring by grouping, or when I'm factoring by grouping, that's when we break things up into pairs so that I can treat each pair like it has its own little GCF. So when I take what's shared out of these guys, we're just going to have an x, and it's going to leave us with 3x minus 4. And then if I look at the right pair, I have a 3x minus 4 there. What do they have in common? They do have a common factor, 1. So it's not that they don't have anything in common. They just have a 1. So the reason I like to do that with our factoring by grouping is we can see that now this piece matches this piece exactly. And we're going to pull those two out as its own GCF. So it's GCFing again. And we get our 3x minus 4. And our leftover pieces are the x and the plus 1. So there are lots of ways to factor, but this is the one I tend to use. So this is our fully factored form here. You do not have to do these with grouping. It's just a way that I find reliable and repeatable. Questions on that first one? Because I know it's been a minute. We're going to try it again. We're going to practice it again with our bottom one down here. We're not always going to be given x variables, and that's okay. We can do it no matter what the variable is. It is still the same technique. It is still the same process. You can factor however you like. If you do not use factoring by grouping, that is totally okay. You do not have to. You just have to be able to factor it. So again, always a good idea to check for a GCF because we'd really like to have one, but we don't have one here. So we're going to have to keep going. We're doing our full either x in box or split the middle, whatever we got. We take our a times our c at the top. 4 times 25 is 100. And our b at the bottom is a -20. So what pair of numbers multiplies to make 100 and adds to make -20? -10 and -10. So what we have here is, again, the same exact thing as if we had 4a squared minus 10a minus 10a plus 25. It's doing the same exact thing. It's just splitting that middle term apart into the pieces it had before we combined our like terms. If you put this through the box, those are the exact pieces you put in the box. So then I'm going to break these up into pairs so that I can factor this by grouping. So I'm going to group these things together. Whenever I have a minus sign in the middle between them right there, I'm always going to pull it into my parentheses because I want there to be a plus in between. Every time. It helps me keep track of signs. It really does. So whenever we're factoring by grouping, you want to have a plus in between. Okay. Any questions? I'm always happy to answer them. You just gotta let me know. Okay, let's figure out what we can factor out of these. What is shared between 4a squared and minus 10a? 2a. So I can take a 2a out, and that's going to leave us with 2a minus 5. And then if we look at our second set over here, we've got 10a, or negative 10a and 25. What do they have in common? Negative 5. Good. If this spot is negative, we're always going to pull a negative sign out. So we're going to have our minus 5. And when we divide a minus 5 out, we get 2a and a minus 5. These two pieces always need to match. If these two pieces don't match, we messed up. They always need to match. Because then I can take them out like they are their own kind of GCF. And we get 2a minus 5. And all of our leftover pieces team up together to get another 2a plus negative 5 or just minus 5. And so you can write it just like this. You can put 2a minus 5 times 2a minus 5. Or we can look at that and go, hey, I know a shorter way to write that. Because that is the exact same thing as 2a minus 5 squared. Either way is fine. I will take both. There are going to be times when it's easier to write it with the squared for other reasons, but I don't care. I was like, it works both ways. Okay, questions on these two? Okie dokie. Because now what we're going to start to look at is we're going to look at some of our special patterns. Because we've got a few special kinds of factoring that it's really good to have some tools to help with. Because like I said, we're going to be factoring a bunch. It comes up in, I think, every chapter from now till May, where we will have at least some factoring. Okay, so there's going to be some times where we're going to have some like shortcuts that are going to be easier. Like familiar stuff. This would be our difference of squares, which we do have a special pattern for, which I'm going to write the formula for up here in just a second. You do not have to know the formula for difference of squares, but again, we are going to be factoring gabillions of times. It's going to save you time. It's going to save you a lot of time. So if we know it, that is best. I'm going to show you that it still works totally fine to do it the long way, but there is a shortcut. So I'm going to put the kind of formula the way we write it up here. And that's when we have two things that are perfect squares. So we usually write that as a squared and b squared, which is two different things. We can put this in factored form where it's going to make two factors. And it's going to have whatever was squared to make the front term in front. So a. Whatever was squared to make the back term in back. One piece gets a plus, one piece gets a minus. Again, you don't have to memorize that, but it will save you a bunch of time throughout the year because we use difference of squares a lot. So the first one I'm going to do our x squared minus 9. I'm going to show you that you don't have to use the pattern, and then I'm going to show you why the pattern is so very helpful to make things way more efficient. Because if we don't recognize it or we don't see it, we can 100% come through here and do the same thing where we have our a, which is 1, and our c, which is minus 9, giving us a minus 9. And our b isn't there, so we have 0 b's. What set of numbers multiplies to make negative 9 and adds to make 0? Negative 3 and positive 3. So again, I could rewrite this with our x squared minus 3x plus 3x minus 9. That's the same thing. If I combine those like terms together, 100% would give me what we started with. When I break it up into pairs, we're going to get our x times x minus 3. And we have a 3. times x minus 3 when we factor that. And so that gives us our x minus 3 with the x plus 3. Which, again, we could take the shortcut from here because we have an a value of 1. We could use the minus 3 and the positive 3 to get those. That would be a shorter shortcut. But this is the best shortcut because we could just go, hey, wait a second, I know what squared gives me x squared. That would be an x. I also know 9 is the same thing as 3 squared, so we have what's in the front is our x, what's in the back is our 3. So we're going to look at some that down here below. These ones are going to be made so much easier by using our special pattern. Again, first step whenever we're factoring every single time, no matter if it is difference of squares or not, is we got to check for a GCF. Does this one have a greatest common factor? No, but it's a good idea to check anyway most times. So we're going to use our special pattern on this one, but that means I need to know as a whole what was squared to make 16x squared. 4 and x. What squared gives us 49? 7. So my a is 4x. My b is 7. So when we put this directly into our factored form, which we can totally do, makes this way shorter, we're going to have our 4x in the front. The 7 goes in the back. One set gets a plus, one set gets a minus. It genuinely does not matter if you put the minus in the front or the plus in the front. Either way is fine. It does not matter. I tend to put the plus in front just because that's the way my brain likes to do it. Okay. Questions on that one? Okay. I like questions. You're welcome to ask them. Let's look at our third one like this. What are we going to do first? I was going to say, I've heard two different options. I heard the 15 and A. I 100% see where we're coming from, but I actually want to listen to the other option we heard, which is to check for a GCF. Do you guys remember the shortcut for how to tell if something's divisible by 9? If the digits in it add up to a number that's divisible by 9, it is. So 2 plus 2 plus 5. 2 plus 2 plus 5, so that's 9, right? Is divisible by 9. So 225 is divisible by 9. It is. If you add up the digits and it's divisible by 9, it is divisible by 9. What is 225 divided by 9? 25. So even when we see something we go, ooh, difference of squares, nice. Still check for a GCF. It makes a difference. Because if we factor a 9 out, that's going to give me 25a squared minus b squared. I'm not saying you can't get the right factors the other ways if you go straight into difference of squares, but then you would get our 15a squared and 3b squared, and you've got a greatest common factor inside both of your pieces, which you're then going to have to factor both of them. GCF saves you from that. So we can take this and we can go straight into our factored form from here. You do not have to write it in this way. Whoa, that was not the laser pointer. There we go, this way. You do not have to write it this way. If writing it this way helps you, write it. If writing it this way does not help you, don't write it. But we can go straight into our factored form here because what squares to give us 25a squared? 5a. So we have our 5 and our a, and that goes in the front. What squares to give us b squared? Just b. One piece gets a plus, one piece gets a minus, and I'm going to be intentional and I'm going to switch them. So I'm going to put my minus and then my plus. Mostly so we see it doesn't have to go plus and minus. It does not matter. It's just my habit. I try and let you know when it's something that's my habit versus math law, because I have it ever hard. Okay. So difference of squares should be familiar. questions. Yes?
Could you do it if you do difference perfect squares in the 225? So like,
Say louder. City.
instead of taking the common multiplicator, could you just do it from 15?
If you did it with the, up here where we had our 15a minus 3b and 15a plus 3b, notice in both of those factors, you have a 3. So I would need to then come through and factor the 3 out to get our 5a minus 3, or minus b. And then we'd have another 3 coming out of this one to get a 5a plus 3. So you'd have to factor again. If we then just multiply those together, we get exactly back to what we had down there. So you can do it. You just have to double check and see if there's another factoring you need to do.
Okay.
So I think it's easiest to think about GCFs first. But if you want to check for GCFs at the end, good luck. Because it will also make your numbers way bigger. If we're giving you gargantuan numbers, double, triple check for a GCF because they're mean, but they're not usually cruel. But it's Precal. They're not always nice about it. Okay? Let's do another kind of special pattern that we have seen before, but it's probably been a while and we haven't used it super duper frequently. We are going to use difference of squares a bunch, and we're going to use this next one a bunch. But it's probably been a minute since we saw it. And that would be our sums and differences. This one we can use as a plus or minus of cubes. So we're going to look at some perfect cubes. So it's going to be one of those things that's helpful to remember some of our cubes, like that 2 cubed is 8, and that 3 cubed is 27, and that 4 cubed is 64, and 5 cubed is 125. We don't typically ask you guys to come up with a ton of cubes off the top of our head. If you can get to 5 or 6, you should be fine. Anything other than that, we're going to use calculators on. It's not going to be... Like, I'm not going to give you the cube root of 743. I'm not that mean. All right, so with our sums and differences of cubes, we look at them and go, ew, I wish that was cleaner. So we got to remember to use soap. What the soap is, that tells us what signs are going to be in this formula. So whatever our statement is in our problem, we always start with our same sign. So if it has a plus, our first sign is a plus. So the soap helps us remember our same sign. Then the next sign in our formula is going to be the O stands for opposite. There we go. As I say, it's there. It's just in the deep storages. Opposite. And then the A and P go together because that means always positive. So if it helps you to write these out separately, that is totally valid. If you have an A cubed plus B cubed, when we're writing out these factors, it's always going to be the single factor first. So we're going to have our A with the same side. It would have a plus B. Then it's the first piece squared, so A squared. Our opposite sign, so instead of a plus, we use a minus. The product, AB. And then it's always a plus, and the last piece, squared, B squared. So the chunks themselves are exactly the same. AB, A squared, AB, B squared. It's the signs that change. The only thing different between a sum of cubes and a difference of cubes is the sign. The only thing different is the sign. So everything else lines up exactly the same. It's just instead of A plus B, we're going to have the same sign that we started with, which was the minus sign. And we're going to have our A squared with our opposite sign. So this time it's a plus. AB, and it always ends with a plus here for our B squared. Again, if these do not help you, don't write them. If this does not help you, don't write it. If you want them all, more power to you. Write as much as you want. But if there's something up here that does not help you, do not write it. Okay? Okay. 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 We're going to practice this a few times, or a couple times. With our sums of cubes, we've got sums on both of these, but that's okay. We can do differences too. So we've got up here our x cubed plus 64, and we're going to put this in factored form. Again, we should always check for GCFs first. I don't have one because I don't even have a coefficient on my x cubed. So we're ready to rock and roll. I suspect this to be a sum of cubes, partly because it's on the sum of cubes page, partly because I see a cube. When in doubt, look for that. So I'm going to rewrite this real quick so I can put this the way I did for our difference of squares, because I know if I take x and cube it, that's what gives me x cubed. What cubed gives me 64? 4. So when we put this into our sum of cubes factored form, what we're going to have is the front piece, which was our x, getting the same sign, and then we have our b. So we're going to have our x plus 4. Then in the next piece, we get our first piece, so that x squared. Then we get our opposite signs. We're going to have our minus. The front times the back. So x times 4, which I'm going to write as 4x. If you want to put x4, it's not wrong. It just feels weird. But you can absolutely do that if that works for your brain. 4 and x. We multiply them together. And then our last piece, we have our plus, and then we need our b, or our second piece, squared. What is 4 squared? 16. If you want to write it like this first and then simplify, totally valid. Or you can go, wait, I know 4 squared. That is 16. This will almost never factor. I'm never willing to commit to an always, because there's always some weird case out there somewhere in the deep recesses of math. But I have never seen it factor. So it is a very, very safe bet that that piece will not factor back up. It's going to stay looking like a quadratic. So we do have to follow this pattern, and we have to use that. So we're going to need to know this pattern. We're going to practice it again. We've got this one on the bottom here. This 2y cubed plus 250. What do we notice? We've got a GCF because 2 is not a perfect cube and 250 is not a perfect cube either. So we can't do anything with it if it's not a sum or difference of cubes, because we don't have the information to factor any other type of cube all by itself. So first thing we got to do is take out a greatest common factor. We've got a GCF here of 2. That's going to leave us with a y cubed plus 125. Now we have a sum of cubes that we can work with here. Because what cubed gives us 125? 5. So we can come down here and go straight into our pattern. This 2 is just going to kind of sit out in front. We're using our sum formula, so we're going to look at that one. So we know we have a y in the front, and we use our same sign, and we decided that 5 cubed gave us 125. So there's our first factor. Then we're going into the second piece where we take our guy that was in front, our y that cubed, and it gets squared. Then we're going to use our opposite sign. I need to multiply the 5 and y together, so we get 5y. We always have a plus sign here, and then we get our 5 squared. 5 squared, also known as 25. And again, that won't factor any further because we don't have any pair of numbers that'll multiply to make a positive 25 and add to make negative 5. So it doesn't factor further. It's going to give you an irrational root if you try and solve it. So that's as factored as it goes. Okay? So differences are just the same. We still follow that SOAP pattern. It's just different numbers. Okay? We're going to do one more that's like one of the most obnoxious ones on the homework. And it's very much like, I want to say question like 90 is 90 something. 96. It's very much like 96 because the above 84 stuff is where it starts getting a little weird, but it's mostly just factoring by grouping or factoring however works for you. So if we look at this one here, it's kind of messy. We've got x squared minus 9y squared plus 4x plus 4. So I see a couple of x's and I see one y in there who's just causing problems. So I'd really like if we could ignore this guy, because then I see x squared, 4x, and 4, and that looks like something we know how to deal with. So what I'm going to do is, since these are all being added together anyway, I can reorder them in whatever order I want. So I'm going to push this 9y squared to the very, very end and deal with him later. So I'm going to rewrite this as x squared plus 4x plus 4, and then the minus 9y squared. That is the most crooked line I think I've ever written. That's okay. That's what happens when I don't have lines on the screen. So then take a look at just this piece where we have all these x's. Do we notice anything with that? It's a perfect square. If I factor this, pair of numbers that multiplies to make 4 and adds to make 4, this is going to be x plus 2 times x plus 2. So think through your factoring here. We've got our positive 2, positive 2. You can write that as x plus 2 times x plus 2, taking the shortcut because we have an a value of 1. Oh, snap, using that tool. So if it helps you to put it down like this, put it down like this. But what we really need to notice here is this is the exact same thing as if I have x plus 2 squared minus 9y squared. Do you notice anything about that? It's a difference of squares. I have something that's got a perfect square, subtracting something that is a perfect square. So this is now a difference of squares. We're doing a couple rounds of factoring here. So this we can put into the difference of squares pattern because I know what squares to make the front piece and we know what squares to make the back piece. So we can go straight into our pattern here where I know my x plus 2 is the thing in the front because that's being squared up here. What squares to give us 9y squared? 3y. One of these sets gets a plus in here. One of these sets get a minus. So it's a difference of squares dressed up weird. Okay, so we had to factor to get down there. So some of the ones on the 1-3 homework have a couple of rounds of factoring, especially when you get past up into the 80s. And you bounce around, it's not that many. So like 88 is got at least 2 rounds. 94's got 2 rounds. 96 has 2 rounds. This one is very, 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 very much like 96. Very, very much. Okay? The rest of them, aside from 86, only have 1 letter anyway. So 96 is the only one. 96 and 86 are the only ones that use more than 1 letter. Aside from 18. Okay, so looking at 1-3 for when you're moving forward on stuff, we are going to do the quiz tomorrow. So we are not going to have a ton of time to work through notes after the quiz. We'll have a little bit of time. So I have pushed 1-3 because I also know it's a ton of questions. I've given us a little wiggle room on that. It's going to be due Monday. Yes, dear.
So is all the rest of the homework going to be pushed back as well?
Probably not. I don't bank on it until I tell you like the dates on it. Because we try and keep on it because we don't want to wind up pushing the test. Then we'll wind up with some test straddling a break somewhere.
No, because then I thought X.
So we are going to do the quiz tomorrow. So make sure you look through your homeworks 1-1 and 1-2. The quiz is on sections 1-1 and 1-2. So check those, look through them, look through the answer keys. Answer keys posted on Canvas.